What up? It's your boy C Rizzy coming at you with the remaining problems on our Unit 3 assessment coming up. So, determine all the zeros, number 13. So for this one, essentially we're just setting this equation equal to 0. So we can say that this is in parentheses. So what we have is x equals 0, which represents that first x. And then x squared plus 4x minus 12 equals 0. So we automatically get 1, 0 from that first x. And then we can do a little diamond method here. Negative 12 on top, 4 on the bottom. Factors of 12 that add to 4. I'm going to get a positive 6 and a negative 2. So then what does this become? X plus 6. X minus 2 equals 0. So my other two zeros are negative 6 and positive 2. And again, we've made mention before that another way to verify that this is correct is that if you were to put that whole equation into your graphing calculator, you would be able to see your zeros on the graphing calculator. Number 14, 1, 0 for x squared minus 10x plus 169 equals 0 is x equals 5 plus 12i. What's the second 0? So this comes from quadratic formula. So when we do quadratic formula, right, we always end up with negative b plus or minus the square root of everything divided by 2. Well, it's telling us that one of our x's is already 5 plus 12i. So they already covered the positive x value. So then what would the next x value be? Well, it would just be the minus part of it. So it would just be 5 minus 12i. So your second 0 is nothing more than just the same thing, but with the plus sign switched to minus. Several points are plotted on the graph. Which one represents the zeros? Again, you could plug this into the graphing calculator and solve it, or looks like we have another box method problem, or diamond method. Negative 8 over 2. Factors of negative 8 that factors of negative 8 that add to 2. That would be a positive 4 and a negative 2. So this breaks down to x plus 4, x minus 2, and then don't forget to bring down the x minus 6. So my zeros are x equals negative 4, x equals positive 2, and x equals positive 6. And those letters are D, A, B for my zero values. What are the solutions of the equation factor completely? So this looks like another diamond method problem. So do a little diamond method here, except this one, we have a times c, which is 2 times negative 42, which is negative 84, and a positive 8 on the bottom. Factors of 84 that get you 8. That would be a positive 14. Do a different color here. Positive 14 and a negative 6. So now what changes here, right? Is that this, whenever our a is not 2, this turns into the reverse box method. Right? We only have to do diamond method when our a value in front of the x squared is 1, but when our a value is not 1, we have to do reverse box. Right? So the 2x squared goes in this box, the negative 42 goes in this box, and then it doesn't matter which one I put where. I'll put 14x there and negative 6 here. What do we get here? So it looks like I'm going to get a Looks like 2 is going to go probably, well, let's just see. I'll put 2 here and x here, which means that this needs to be a positive 7, and this needs to be a negative 6, which appears to work out. So now this becomes 2x minus 6 times x plus 7 equals 0. So then we have to do 2x minus 6 equals 0, x plus 7 equals 0. One solution, x plus, what happened here? This was 7. One solution is x equals negative 7. And I'm running out of room here, but I'll add 6 to both sides. I'm left with 2x equals 6 divided by 2, x equals 3. So my two solutions end up being x equals 3 and x equals negative 7 for my solutions. Okay, going into the extra credit problems, rewrite this equation in standard form. Okay, so to do this, I've got two sides of the equation. I need the right-hand side to equal 0, and I need to simplify the left-hand side too. So on the left-hand side, it looks like I'm doing a little bit of box method. So let's do that first. Do that over here. So I get 2x and 5, 2x and 5, which gives me a 4x squared, a 10x, and a 25. And I need to do a little bit of distribution over here. So at this current moment in time, what am I looking at? I'm looking at what's in my box, 4x squared plus 20x plus 25 is equal to whatever I distribute in here, which is a positive 10x and a positive 3x squared. All right, so I got to move these. I got to move them to the left-hand side. So I'm going to subtract 10x over here, and I'm going to subtract 3x squared over here so that I can assure I get 0. And this becomes x squared plus 10x plus 25. And now I'm in a perfect standard form. And then it wants us to solve by factoring. Well, a is 1, so this is just a little diamond method, and that's all. 25 and 10. I get 5 and 5. So this becomes x plus 5. Apologize for the phone. X plus 5, which is x plus 5 squared. Okay, number 18. Let f of x equal 2x squared minus x plus 1. Let g of x equals x minus 4. Which statements are true? Select all that apply. 1 root of f of x equals negative 4. Could be true, but we're not sure yet. 1 root of f of x is 29. Okay. If f of x is divided by g of x, the remainder is 29. So let's try that one. So we can divide, use a little synthetic division here to divide 2, negative 1, and 1. 4 times 2 is 8. This is 7. 4 times 7 is 28. My remainder is 29. That works. My remainder is 29. But if my remainder is 29, that doesn't mean my root is 29. And negative 4 is not a root, because if it was, I'd have a remainder of 0. That also means this is not a factor because of the remainder. So g of x is not a factor due to the fact that I have a remainder. So I have two answers, C and G. Okay, x cubed minus 81, excuse me, x to the fourth minus 81 can be written as, this is just difference of squares a couple of times. So x to the fourth minus 81 can be written as x squared plus 9, x squared minus 9. Took the square root of both x to the fourth and 81. But this is also difference of squares because I can take the square root of x squared and the square root of 9. So the x squared plus 9 stays because that's not what a difference, right, subtraction is. Difference of squares. So now it looks like this is my a, this is my b, this is my c. So my a is 9, my b is 3, and my c is negative 3. And technically, b and c could switch. It doesn't matter. But a has to be 9 in this form. Okay, for the unknown polynomial function, p of x is p to the 4 plus 2 equals 2. Which factor satisfies this being a factor? Well, to be a factor, we have to set this equal to 0. So if I wanted this to equal 0, I would subtract 2 from both sides, and p of 4 would equal 0. So that's a factor, which means that x equals 4. And how do I write x equals 4 as a factor? It's x minus 4. And again, I could double check this if I wanted to. If x equals 4, or if I plugged in 4 here, 4 minus 4 equals 0. And if I plug that in on top, 0 plus 2 is 2, and that satisfies the equation, if I wanted to double check. Okay, but I'm going to erase that so I don't confuse people. That's really all you needed to know. And lastly, factor this completely. I see 1, 2, 3, 4 terms. 4 terms means I'm going to try factor by grouping. And if factor by grouping doesn't work, well, first I'm going to check for a GCF. There isn't one. So factor by grouping. If that doesn't work, then it's prime. I can factor out an x squared. I'm left with a squared minus 2c. And I'm going to write x squared in a different color, which means that for factor by grouping to work, a squared minus 2c needs to fit on the other side. Is there something I can factor out that gets me that? Yep, it's y. So then my solution here is x squared plus y, the two values in front, a squared minus 2c. All right, that's all.